Hello students, in this video we're going to compute the divergence and the curl of this vector field. So let me get that definition up here. Um, so you see that this vector field, I've just shown you the 2D impression. So this is as if you're looking down upon it, but you can imagine a bunch of arrows shooting out towards you. So it's like a ball with a bunch of arrows shooting outward. But sometimes the picture gets a little cluttered, so I think it's just easier to see if you're just looking at it as a projection down onto the XY plane. Okay, so here are two ways to write this vector field. And first I'm going to compute the divergence. So remember the divergence of the vector field is the grad dot f. So it's a dot product, so we're going to get a scalar. So the grad operator is ddx in the first component, ddy in the second component, ddz in the third component. You dot that with this vector xyz. Now something I want to point out before I proceed is that sometimes people call this the position vector, this vector field. This is called the position vector. So no matter where you are, um, you just you pick a point and then you just have a vector starting from that point. Okay, so what's the divergence of this position vector? You just apply this operator to the first component, add it to the operator applied to the second component, add that to the operator applied to the third component. So dx dx plus dy dy plus dz dz is just 1 plus 1 plus 1 is 3. So we have a positive divergence. We'll talk more about the physical interpretation of that, but when you see a vector field like this, um, we expect to have a positive divergence, and we just would use the term that that the vectors are diverging away from the origin here. And then I'm going to compute the curl rather quickly. The curl is very easy computation here. So the curl of the vector field is, remember, grad cross f, and I just put the ijk's up there. I put the gradient operator in the second column, and then xyz, which is the position vector, in the third row. I think I might have said column, I meant row. Okay, so then I just apply the definition of curl, and you can see that the operators, they seem to just miss the variables here, right? So ddy of z, dz of y in the first component, ddx of dz, ddz of x in the second component, ddx of y, and dy of x. So all those are going to turn out to be 0, and you get the 0 vector. Keep in mind that the curl is a vector. So that's 0 in each of the components. So this vector field, which has positive divergence, has 0 curl. All right, good luck.